Welcome and thank you for joining us. In this event, we'll be exploring the critical role of engine and component remanufacturing as part of the circular economy. We're excited to dive into this important topic with all of you. During this event, all participants will be in listen-only mode. If you have any questions, please submit them via the Q&A button at the bottom of your screen. We encourage you to ask questions at any time and we'll address them as soon as possible. Please note that this event is being recorded. The recording and presentation will be available on the Engine Technology Forum's website shortly after the live event. I'm pleased to introduce our first speaker, Alan Schaefer, the Executive Director of the Engine Technology Forum. Alan?
Thank you, Josie, and good morning, everybody. Thank you for being with us this Monday morning, bright and early. Nice to have you all with us. As Josie said, we are the Engine Technology Forum, and just a quick word about us. The forum is an outreach and educational-based association that's dedicated to promoting a greater understanding about the benefits of internal combustion engines, fuels, and the range of technologies involved. We are delighted to be here today with the support of our membership, and they are represented on today's call, leaders in advanced engines, components, and fuels technology. I want to welcome all of you attendees, and we'd like to take a quick glance through our membership, or excuse me, our attendance list, and find that we have representatives registered today from government, municipal, state, and federal government, as well as a range of other participating entities, including research and technical institutions, NGOs, academia, fleet managers, and service and parts suppliers. So welcome to everyone. And we have quite a diversity of attendance representing the United States, Canada, the European Union, India, and Japan today. So welcome to everyone. We'll do our best to cover the broadest range of issues here. And without any further ado, let me just say one or two opening remarks about internal combustion engines. They are key to key sectors of our global economy, and those you can see listed here. And I doubt that not too many of you are not unfamiliar with the key role that internal combustion engines play. We like to think of internal combustion engines, gas, diesel, natural gas engines, as ones that are part of the energy future, including using a range of different fuels, both renewable biofuels, hydrogen for internal combustion engines, and also as part of electric, as being part of that holistic energy future that we're all thinking about every day. Zeroing in on the sustainability of internal combustion engines a little bit more, how do we think about those in the future? Today, we know that they have increasing efficiency, they achieve near zero emissions, they're able to use renewable and low carbon fuel capabilities, and as you're about to hear, one of the key attributes is also their remanufacturability and rebuilding ability. So these engines last a long time, and that's a high value as you're about to learn. Today's session is going to cover these topics here, including how remanufacturing contributes to a circular economy, what role do component manufacturers play in remanufacturing, and we'll also get into how emissions control technologies factor into remanufacturing. So without any further ado, let me introduce our speaker lineup for today. We are delighted to have representatives from leading companies that are working in this field, and we're going to hear from each of them momentarily. And so our session today will last about 75 minutes. We'll have plenty of time for questions. At the end, we start to collect questions right from the beginning, so feel free to enter your questions in the Q&A feature on our Zoom meeting platform here. So without any further ado, let me begin our program by welcoming Patricia Covington from Cummins. Patricia?
Thank you so much, Alan, and good morning, everyone. It's an absolute honor to be with you today to talk about the remanufacturing and reverse logistics process for Cummins. So I'll start, if you go to the next slide there, Alan, I'll start with a little bit of a history lesson in terms of how remanufacturing started for Cummins. So Cummins' involvement in remanufacturing actually began in the the late 50s. And it was in response to technical field and service problems with fuel systems and air compressor components. So the initial effort began with Cummins factory repair of returned goods, which were essentially rebuilt in the Columbus, Indiana area, and later sold back to our distribution system. The company found that it was more cost effective and more efficient to establish regional rebuild capability. And thus 5 locations were selected. Oh, it was in Arlington, Texas, Charlotte, North Carolina, Los Angeles, California, Portland, Oregon, and San Francisco, California, all parts of our distribution network at the time. By the early 60s, Cummins began to evaluate centralizing the rebuilding capability. And thus our leadership approved what was then a pilot operation in 1966, choosing locations there. You see Memphis, Tennessee, Los Angeles, California, and Chicago. As things continue to progress, we found to be true a few factors that led us to then expand and consolidate the operation even more. It was good business opportunity to make money for sure, but also lower customer repair costs and downtime. And that was really, really critical. So then we thought about how do we establish better standards and centralize a little bit more. So you'll see as the timeline progresses, in the late 70s, the expansion of Los Angeles and the building of the initial remanufacturing operation in Memphis, Tennessee came about. And thus Diesel Recon, as it was known then, was an official operating division for Cummins. So over the years, we've continued to focus on how do we look at remanufacturing of our various components and our whole goods engines, and continue to optimize our footprint with the same fundamental purpose, which is to have specialized facilities using factory standards to deliver remanufactured product with like new performance for uptime and supporting our customer sustainability and our environmental sustainability as well. So where we are today, we are now located in the US for sure. Mexico, India, and Brazil is where our current footprints are. So if you go to the next slide, we'll talk a little less about Cummins history and a little bit more about the actual remanufacturing process. So when you look at remanufacturing, it all starts with a new engine or a new component, a new product. And this process map actually illustrates what is our repair process based on when a product reaches the end of its useful life. It is then when it enters the remanufacturing cycle. And I'll go top down here very quickly on the graphic. One of the most critical elements is what we call core. It is essentially the dirty product. So once that repair cycle starts and that product has reached the end of its useful life, we want that dirty product back, that dirty core back. That dirty core is the most important element. And for us, there's a very huge reliance on what we call reverse logistics to be able to get that core back from our customer base and to make it easy for them to return. So then once it gets back into our possession, we're then able to get that core disassembled, get it cleaned, and it then enters the official remanufacturing process. Whatever that salvage technology is for that specific component, we run that process. So our engineers are always happy to work in the remanufacturing space because it, for many of them, is a playground to think about the different salvage technologies that are required depending on what the component is. From there, it enters into the reassembly process and then onto inspection and test. You heard me say earlier, it is like new. So same quality standards, same expectation as new. It is then remanufactured and sold to the customers, and it then goes back to the very top to re-enter the life cycle process. If you go to the next slide there, Alan, I'll talk a little bit about how this has helped us in specific times in terms of mitigating supply chain risk. So not only is it a really, really good business opportunity, it is most important for our customers. So when you think about how it buffers against distribution in terms of product availability, whenever suppliers are constrained, it gives us an opportunity to think about how do we utilize our remanufacturing technology to offset whatever supplier capacity may be, whether that is external supplier capacity for new components or our own internal manufacturing capacity. So it gives us an opportunity to have shorter lead time than the new product. Lower raw material consumption, again, back to the environment. We want to make sure that we're always doing the right thing. So as much as we can remanufacture, the better for the environment, because we are not relying as much on the raw material. And then more specifically, during the pandemic period, there were, I don't think it's a surprise to anyone, a lot of us had constraints. A lot of our suppliers were significantly constrained. So it gave us an opportunity to then think about even some product that we were not remanufacturing or did not have plans to remanufacture as soon as expected, but we were able to quickly get the product into the remanufacturing process and offset. So on the right side, just a few other points in terms of benefits. It is absolutely cost effective during periods of uncertainty. But again, it gives us an opportunity to offer to our customers an alternative option to new. And it also gives us that through that opportunity, we've built really, really strong relationships with customers and helping them understand how to provide options for their end user customers and have sustainable supply chains. All right, if we go to the next slide, this is the one that tells what I believe to be our full story in terms of the life cycle. So these dates you see here, I'll start to the left. This is an example of a product throughout a very lengthy life cycle. So you'll look there for a product that we released in 2007. There's an early stage where it's not in remanufacturing yet, but we want to get that dirty core back. So we want to release that remanufactured product early on so that we can start the core collection process. Depending on the volume, depending on the usage out in the field, we will start to collect that core. And for a period of time, we will build a bank. So we want to build the bank of core so then when we actually start the remanufacturing process, we have enough to make sure that we are at least 50% usage for whatever that component or engine may be, so that we can offer the customers that price point that we prefer and that they prefer and that they ask for. So once the remanufacturing starts, it can be 12 months, it can be 24 months. It's solely dependent upon our ability to collect the core from the field. We will then start the remanufacturing process, and that reman process often starts before the end of the new production. So in the example of an engine, new engines and reman engines can be manufactured at the same time. So at any point in the process where it becomes mature, then the new engine platform may cease to exist and go on to a better, bigger, better engine or newer engine, and we will still have the ability to offer those customers the repair parts and the whole reman engine for a period of time. And that mature life cycle can span, as you'll see, 10 up to 20 years. It just depends on the product. We can remanufacture some components more than other components, but again, it goes back to the capability that we have. And eventually there will be a declining phase where you just can't remanufacture that component anymore because it has sort of hit the brick wall, and it is then in the declining phase. So that is when we will start to see the core return from the field at higher rates than expected. And that is when we start to think about getting that product out of the remanufacturing cycle, thus ending the life cycle for that specific product. And again, the years can vary depending on the component. Cylinder heads are different from turbochargers, from injectors, and other components. And so that is the life cycle for remanufacturing as it exists for Cummins. I think it's very similar in the industry for others. And so I think, Alan, that is my last slide if we want to go on to the next one.
Thank you very much, Patricia. That was a great introduction about remanufacturing and the life cycle there. I think a lot of people are going to be thinking about that last graph there for a long time. That really tells the story. I do see a couple of folks have submitted questions. We'll look forward to answering those as we go along. And thank you for that. Let's move on to our next speaker, who is Kevin Schrag. He is manager of John Deere's Reman. Welcome, Kevin.
Thank you, Alan. Welcome to all of our guests today. I'm happy to be here. Again, my name is Kevin Schrag. I lead our Reman operations for John Deere globally, based out of Springfield, Missouri. Go ahead and go to the next slide. Really what I want to discuss here over the next 10 or so minutes, I want to just give a very brief overview of John Deere and where our power systems and our Reman business fit within John Deere overall. And I want to talk really about the definition of Reman, how we have define that, and talk through the value that Reman brings to our customers. First of all, John Deere. So John Deere was founded in 1837 by John Deere, the man, and it started really with the innovation of a self-scouring plow that John Deere invented at the time that really revolutionized agriculture. Since that time, John Deere continues with a legacy of innovation in multiple different segments. If you go to the next slide. Today, John Deere is over 100 locations. This is factories, engineering centers, marketing centers, and very much a global business with the intent, of course, to continue to grow globally. If you move forward again, we are nearing 80,000 employees, really with an aligned objective and a mission of providing equipment for our customers to feed and to clothe and to develop infrastructure for a growing world, for a world of 8 billion. So that's a bit about John Deere. If you move forward again, Alan. John Deere Power Systems is a division within Deere & Company, and it is a division that Reman rolls up under, but it's really a division focused on how do we power our machines, how do we power our equipment. So anything from internal combustion engines, which would be really the history and will continue to be an important part of the portfolio, to drivetrain, axles, electric drives as well. And then more recently, with a majority stake acquisition of a battery manufacturer, Kreisel Electric joined John Deere here a few years ago. So we're continuing to invest in what the future could look like with battery electric as part of power systems. And again, Reman falls underneath that. If you move forward again, Alan, the global footprint of our John Deere Power Systems business is shown here. But all of the remanufacturing is done out of our Springfield operations in Springfield, Missouri, serving our customers really across the globe from Springfield. And within Springfield, we have multiple different facilities. Again, if you move forward one more. We are actually operating out of 6 different facilities. We have an electronics business. Electronics remanufacturing is certainly unique as compared to heavy equipment. Our main facility where we do machining, assembly, test, paint, and pack. We have our global core center where we receive all of the core. Patricia mentioned the process of core, and really how we manage core is really critical to the value that Reman can bring. And then we have 3 additional warehouses that are really all about core management, core warehousing, and receiving. Core is what makes Reman unique. It's what fuels the ability to offer a lower priced offering for our customers, and it's really critical to the Reman business. We operate in Springfield with just over 500 employees, around 660,000 square feet, and we continue to invest in Reman. I think that's an important point. We're going to be breaking ground on a 120,000 square foot expansion of our global core center, so we're really excited about continuing to invest and grow in this space. So switching gears here, I want to talk a little bit about what is remanufacturing. And Patricia went through kind of the process from new product all the way to Reman product. It's really important that we have an aligned definition of what remanufacturing is. It means a lot of different things out really across the globe. And the Remanufacturing Industry Council is an industry-wide group that's come together. The RIC really has 3 main objectives. One is collaboration and collaborating across member groups. The second is education. And the last is advocacy for how we can expand the remanufacturing overall. And it's made of members that are much broader than just heavy equipment. It's made of members that are remanufacturing anything from furniture to ink cartridges to really across the whole broad spectrum. Several years ago, the RIC put together an ANSI standard, really to drive clear definition of what remanufacturing is. And I won't read this definition to you, but essentially it's a comprehensive process. It delivers a like new performance, or in some cases better than new, and it also delivers a warranty that would be equal to or better than the new product. It's important that it's not the same as recycling or repairing or rebuilding. All of those have a place, but it is different than those. And really, this definition was intended to educate, but also to drive accountability. In my view, it holds remanufacturers to a standard to ensure that we deliver to the expectations of remanufacturing. If you go to the next slide, a bit about remanufacturing. And one of the challenges that we have in remanufacturing is just the complexity. So this is the Deere product portfolio for reman. You can see engines in the upper left, but anything from fuel, transmissions, axles, hydraulics, electronic components and displays and engine control units and receivers, and then rotating electrical components, starters, alternators, along with turbos and additional fuel components. So it's very broad. I think one of the unique challenges, even if we were to focus on engines, our objective is to serve the customer throughout the life cycle. And we're offering remanufactured engines for the latest final tier 4 emission standards, the latest equipment that's put out there. We also offer all the way back to engines that were put on machines in the late 70s, really with the intention of keeping customers throughout the life cycle of the product running and effective in the work that they do. If you go to the next slide, Alan. So I want to spend a few minutes here really highlighting the value proposition that Reman brings. I think this is pretty consistent across the industry, and clearly this slide is from a Deere viewpoint. But we talk about value in terms of the customer, the dealer, the business, and the environment. And ultimately, all of these need to be, and all of these segments need to see the value for this business to make sense. For the customer, the value is primarily around offering a lower priced alternative to keep their equipment running. So generally, we'll price our products up to 30% less than a new equivalent. Of course, we're able to do that through the usage of core and the recycling of that material. But importantly, it's not just a lower cost. It's a lower cost with the confidence that comes with a like new product, the confidence that comes with a product that's warranted to the like new. In some cases, we actually offer a better warranty than the new equivalent would get. And certainly the confidence of having the dealer and John Deere backing the product. For the dealer, there's also tremendous value. And one of the biggest values that our dealers see with Reman is enabling them to grow their service capacity. We consider Reman a force multiplier. By using a complete solution, be it a complete engine or a complete transmission or axle, they're able to, first of all, get the customer up and running quickly. But secondly, the technician that would otherwise be rebuilding or taking time could serve a customer that may not be served without a Reman solution. So tremendous value for the dealer. In addition to that, the dealer, Reman for the dealer mitigates their risk. Certainly, we're warranting the product, and it mitigates any risk they would have from a rebuild. And through their ability to leverage Reman and serve new customers, they're able to sell additional service and additional parts as well. And then finally, there's tremendous value for the business, and certainly Reman fits into the broader aftermarket strategy. It's a key part of our broader aftermarket strategy with the intent of serving customers well into the life cycle, providing solutions for them well into the life cycle. It also allows the business to reduce warranty cost overall. And certainly it's less cyclical than our complete goods business. So there is tremendous value in Reman for the business. Last, but certainly not least, is the environment. And this is super intuitive, keeping product out of landfills, keeping product out of recyclers' furnaces or out of hedgerows rusting away, which sometimes you see old equipment in that condition, is a tremendous value, certainly for our world. So I think with that, I will turn it over to Jeff, who's our next presenter.
Great, thank you very much, Kevin. That was wonderful insights there from Deere. And now our next speaker is Jeff Sutherland. Jeff, good morning, welcome, and I'll turn it over to you.
Yeah, good morning. Good morning, everybody. I guess it wouldn't be a Monday if I didn't have some problems with my computer, so I joined a little bit late. I don't know if I missed any introductions or not, but apologize for that. But I'm Jeff Sutherland. I'm the drivetrain product manager for Caterpillar Reman Division and the chief engineer. Been with Caterpillar for 30 years. This is my 30th year and 10 years in the remanufacturing division. And today I wanted to speak a little bit about a practical issue we have in the remanufacturing that I'm sure many of the companies involved in remanufacturing are familiar with that. And that is our ability to kind of influence design practices as much upfront as possible. Caterpillar, you heard from Kevin and Patricia. They have large companies as well. They're worldwide footprints. Caterpillar's no different, and we literally have thousands of engineers or other employees in Caterpillar, whether it's in purchasing, that can make decisions every single day that affect our ability to remanufacture a product. And so we spend a lot of time and effort in the remanufacturing division trying to influence those design situations or the design decisions as much as we possibly can. We do that primarily a lot of times through education and awareness. We partner with our we partner with our other new site design counterparts to educate them on the importance of reman. We have design guides that are available to them to help them reference when they're doing designs. We try to attend design reviews and be active in those decisions. But the reality is we can't be there all the time. There's just too much going on. And so we're constantly looking for ways that we can integrate remanufacturing into design processes upfront. And today I want to speak to you a little bit about a project we're involved with that the purpose of that is to allow us to do that, to be as integrated into the design processes as much as we possibly can. We're doing that through a partnership with the Remade Institute. Some of you might be familiar with this, but the Remade Institute is a design R&D consortium sponsored by the Department of Energy, whose mission is to reduce embodied energy in U.S. products through the use of remanufacturing, recycling, refurbishing, et cetera. Caterpillar is a founding member and a Tier 1 member of this institute. We've worked several projects related to remanufacturing through this. And today I'm going to talk to you about one that I've been pretty close to, and that is a development of a CAD plugin to help enable design for remanufacturing for Caterpillar and the industry in general. You can see some of the partners we have in here with Train Technologies, the Rochester Institute of Technology. Kevin mentioned the Remanufacturing Industry Councils. They're a partner in this as well. So I want to take a little bit of time just to tell you about this project. If you go to the next slide, please. So why is Caterpillar interested in this? Well, turns out a lot of the industry is interested in this and as well. So you can see the results of a survey that was conducted by the Remanufacturing Industries Council in 2016 that kind of polled the industry on what's important, what are the most significant issues in the future, what are the most beneficial training topics that are needed, and you can see that design for reman or topics related to design reman, core design features rose to the top. So it's not just Caterpillar that's interested in how we can get better at design for remanufacturing. The industry is interested in this as well. And that's why it was such a good fit for the Remade Institute, because that is meant to better the industry for everybody. The types of projects that are run through that are shared with members in the industry. And I think Remade has over 130 partner companies and institutions. So this is shared broadly, and it benefits the industry as a whole. You click to the next one. So Kevin mentioned the definition of remanufacturing. That's important. I'm not going to repeat that, but that's in there. But also as important is the definition or why we need to design for remanufacturing. And I spoke to it a little bit. Is oftentimes our ability to remanufacture something is limited by the decisions that are made. And oftentimes they're not forward thinking, and they can potentially hinder our ability to remanufacture down the road. And so that's the purpose of this project that we've been a part of. And I'll take you a little bit through it. And it really hinges on kind of understanding and predicting and mitigating the failure modes associated with remanufacturing, corrosion, fatigue, wear, those types of issues. How do we account for those upfront and make sure that they don't hinder our ability to remanufacture in the future? They do this, if you could skip to the next slide, please. And so we do this by essentially the software essentially interrogates the engineer's design using a kind of a hierarchy of design principles. And so it looks at the design and it kind of steps through a series of questions that they want the design engineer to answer. And it starts with, can you prevent the failure modes that we talked about earlier? For those of us in remanufacturing, the best way to remanufacture something is not to have to remanufacture it. So what do I mean by that? If when we get our core in, if we were able to just slap a label on that and resell it to our customer, that represents the kind of maximum value we'd ever be able to extract from that core. And every time we touch that core from that point forward, we kind of detract from that value. So obviously the most cost-effective way for us to remanufacture something is to be able to just reuse it. And so we want to kind of interrogate those designs up front, make sure that they can be reused if possible. So that's designing for infinite life, things of that nature. It helps us do that. That's not always possible. So you start stepping your way down that design hierarchy, and you try to minimize those failure rates to an acceptable level so that at least they're making it through one life. That's not always possible as well. So then you might want to consider relocating that failure mode to another less expensive part to repair. And if again you keep going down the hierarchy, that's not possible as well. Sometimes you just want to be able to predict it so that we make sure that we're replacing components prior to failure. And then finally, kind of the last resort is we want to make sure we can restore it. And that's where you start to get into some of the more technical solutions we have for restoring products and salvaging products. But the intent of this software is to really kind of take an engineer through that design principle hierarchy shown here to help them vet their designs and account for the ability to remanufacture upfront. It's a very structured process that it takes you through as you're going through your design. And the next slide kind of gives you a kind of a practical example of that as it applies to a diesel engine rocker arm assembly, which many of you are probably familiar with. But obviously the first thing we want to do is try to prevent that wear from happening. One of the example that's shown here is, this is kind of high tech here, but maybe a magnetic bearing completely eliminate any wear would be kind of the first kind of hierarchy that you want to step yourself through. If that's not possible, then you want to minimize that wear, make sure you have hardened surfaces, etc. If that doesn't do the trick, then you want to try to relocate that wear to a less impactful location. Can you have a sleeve in that design that's easily replaceable if it wears out versus having to replace the entire rocker arm? And then finally, can you restore it? And again, that's kind of the last step we want to consider. And that's, you need to be able to understand, do you have enough tolerance in your design, enough material to be able to machine out something and put another surface in? Can you repair it with some additive manufacturing processes, et cetera? And that's the intent of the software program, is to kind of walk you through those design considerations up front as early as possible in the design process. And next. And so there's a little bit of an advertisement for it. It's not commercially available. Again, it's still in the project. It's still being developed, but it's called Phoenix DFR, DFR standing for Design for Reman. But it essentially walks you through the design kind of hierarchy that we talked about in an anecdotal way, but it also interrogates your design with specific design rules. So you can load in your own tolerances, your own design rules, and it'll interrogate the design. As you can see here, it's asking to make sure it's actually analyzing the distance between the bolt hole and the edge of that cylinder to make sure there's enough material there that if a repair of the thread needs to be done in the future, it highlights that as a potential area of concern, and the design engineer can make a decision accordingly. And so the intent is to be as proactive upfront in the design process as we possibly can. So I liken it to, you know, that we're looking over the shoulder of the design engineer and being able to whisper into his ear to think about some of the considerations for remanufacturing. So we're really excited about this. I think it has the ability to really make a huge difference in our ability to design products for remanufacturing in the future. If you go to the next slide, if you're excited about this topic as well, we have some contact information here. Brian Hilton is the principal investigator for this project. We're always looking for people to beta test the software to identify any bugs or issues or help us understand whether or not it could help your organization in the future. So just leave that with you here. If you're interested to reach out to Brian or myself, we're glad to get you involved.
Great.
That's all I had.
Thank you very much, Jeff. Really appreciate that. Some really interesting concepts there about designing for the future. Boy, it makes so much sense, huh? Let's move on to our next speaker. I just want to remind you that you can enter questions in the Q&A at any time, and we've got a number of questions in there already. Great job to the audience. Keep them coming, and we'll get to those momentarily. Our next speaker is Srinu Gunturu, and Srinu is the Chief Engineer at Stanadyne. Good morning, Srinu.
Good morning, all. Thank you, Alan. Good morning, all. Thank you for this opportunity. I know most of Jeff, Patricia, and Kevin covered the reman on the engine side. I think where Stanadyne and Pure Power is going to come into the component side, where they need components to be able to rebuild the entire engine. So it kind of brings into like both together, like the OEs require the components to be able to remanufacture their engines. So if they don't have pumps, they don't have injectors, they don't have fuel systems that they can able to remanufacture, which where Stanadyne will come in and help in the components for the remanufacture for the service. Next slide. So about Stanadyne, I mean, Stanadyne supplies the critical fuel and air system components for new and aftermarket, on-road, off-road, and also for the military vehicles. And also we have another division called Pure Power, where we do a largest independent remanufacturer of the diesel common rail injectors. So we remanufacture more than 400,000 injectors a year. So our remanufacturing operations support the OE sustainability initiative by reclaiming millions of pounds of waste. And also we are proud to be critical service for remanufactured components, which is not available from any other source. Not only that, we are part of the ICE propulsion, decarbonization of hard to electrify ICE. And also we're going to continue to develop on the gaseous fuels, including hydrogen, propane, other alternative fuels. And also we have a global presence supporting the local transition occurring different spaces. So we have presence in India and North America. And also we have almost like 1,000 independent service dealers through OEM service networks to be able to help support in the component for remanufacturing of their particular engines or vehicles that needs remanufacturing. Next slide. So I'm going to talk about more on the circular economy, why that is important. I think Jeff, Patricia, and Kevin covered some of these slides. I think you're probably going to hear most of the same repetitive of the circular economy. I mean, it's as we are innovating for the future, ensuring the technologies are environmentally responsible is more important than ever, right? And also there is where the life cycle analysis is very important, and then circular economy into play. So it's a life cycle analysis. I mean, you can see where we start from the designing perspective, from where the life takes to the to the user and then comes back into the recycle back into the system. So it's very important by integrating this LCA principles with the circular economy strategies so that we can improve the system efficiency and reduce the waste and minimize resource consumption. And also it embraces the holistic approach, developing the sustainable solutions that address both environmental and economical challenges. Next slide. So I know Patricia has a better slide of how the comments, but I did put together based on what we see as a component manufacturer, how the replacement rate is where we have to, from the OEM factory parts, then becomes the aftermarket service parts, then where we need to be part of that service aftermarket or for the reman, then you can see the growth of births to the peak and also to the decline on the aftermarket service. So early life is like 0 to 3 hours, which is a low replacement rate. And then the midlife is like 3 to 10 years, increasing replacement rate where there is the vehicles accumulate miles, wear and tear components start failing like brakes, batteries, injectors, sensors, and more repairs happen in the aftermarket, but OEM parts are still commonly used. So the late life is like 10 plus years, the declining OEM replacement rate. So as the vehicle age further, the OEM parts become more expensive and discontinued, leading to increased use of aftermarket parts. So some of those parts, like can say like the high pressure pumps and fuel injectors, might still has a high demand for the performance reasons. So that's where Standardine has into making those reman of those fuel injectors and the high pressure fuel pumps, where you have a 10 plus years late life of declining the OEM replacement rate, where the vehicle population is decreased as older cars are scrapped or reducing the overall demand for the OEM replacement, but we still support in that by remanning like 3 times or 4 times of the same injector or the high pressure pump, so that we still support the aftermarket or service markets. Next slide. So how we do it at Pure Power? Previous slide. So keeping for every year at Standardine/Pure Power 500,000 million pounds of waste landfills every year. So we are the market leader in remanufacture for the fuel and air systems. We remanufacture pumps, injectors, and the turbochargers. And also you can see we not only remanufacture our own product, we remanufacture someone else's designed product as well. So we take the core from the incoming core, and we disassemble and we do a component inspection, and we see if we need to have any rework or replace, and we do a chemical wash process through, and then we go through the product reassembly and then retest and pack out. So we follow through the original OEM test specifications to meet the original OEM specs, so that when the end customer gets it, they'll have the exact original OEM injector or OEM product pump. So not only that, like we use like 80% of the original material, probably like that 15, the other 15% is like either a virgin reverse engineering of a virgin component or reworking of the same component, just to make sure that the critical wear areas that we rework to make it back to the original injector. Next slide. And this is just an example. I thought of putting it for the reuse rates, like how we do it, right? Like, I mean, I know this product is not our product, but we buy core and we try to analyze the core and understand how these parts interact and how the wear is like. And then we wash them, and we were able to visually inspect, see like whether how much percentage that I can reuse this. Like, can I use it like 90% or 20%? And do I have to have like the wear is so substantial that I cannot able to rework or replace? I have to do a reverse engineering of this particular component to be able to build a reman injector back or a reman pump back. So the high reuse rate, I mean, I just give an example in here, like the pump housing is like 90% of the pump body, you can use the shaft, you can use 90% of the reman part that you can use back. And there are some low reuse rates like the seals, O-rings, springs, critical valves, where you see a lot of wear, a lot of stress during the run of that vehicle or run of the engine, that you probably have 0% because of the critical nature of the low reuse rates. So you need to purchase the new precision components requiring the new replacements. I mean, it goes same with the OEMs also, like for their engines, sometimes the injector or the pump they need to replace. So they just buy as a brand new, even though that brand new pump and injector is also a reman product for their reman injector. So in other words, their reman engine is fully a reman engine with all the components, even they're using as reman products. I think that's the last slide. Thank you all for this opportunity. I know most of the panelists have covered so many other topics with very similar. I feel this is a different from the component compared with the engines.
Thank you, Srinu. That's very insightful look at the component sector of this, and there are a lot of parts to any particular internal combustion engine, so components are key to that. Let me remind everyone that we are still taking questions, so put those in the Q&A. We'll get started on those as soon as we hear from our last panelist today, who is Marge Ryan with Johnson Matthey. Marge, good morning.
Good morning. Thanks, Alan. Pleased to be with everyone today. And I'm going to round out today's session by talking about the back end. So literally how exhaust gas emissions after treatment is handled, and how we look at doing that in a way that is sustainable from a raw material and embodied energy point of view. Next slide, please. So who are we? Johnson Matthey. We're a UK-based multinational, really broad range of different technologies and catalysts for a number of different sectors and markets, all essentially coming under this heading of catalyzing a sustainable future. And we address that through 4 key pillars, which are on the slide there. And today I'll be talking about the first one, which is driving down transport emissions, and specifically in this case, pollutant emissions rather than CO2, and then coupling that with the 4th pillar, which is creating a circular economy. And this is specifically in the platinum group metals, which are key to the catalysis that enables that emissions control. Next slide, please. Just to give you a bit of insight into how Johnson Matthey is structured, we have 4 businesses. So our clean air business is the one that supplies these automotive emissions control catalysts. Catalyst Technologies specializes in process catalysts for producing things like chemicals and fuels. Hydrogen Technologies makes components for fuel cells and electrolyzers to produce green hydrogen. The common thread running through all of those is the use of platinum group metals, which are incredibly powerful catalytic metals and also very useful in things like durable alloys and so on. So our platinum group metal services business underpins a lot of our capability here. That's the business I come from and sit within, and that provides a lot of services such as the supply of metal and metal-based products, trading, metal account management, market intelligence, but importantly, also recycling. So Johnson Matthey is the world's largest secondary refiner, so that is to say recycler of platinum group metals. And our refineries in the US and the UK really do refine a lot of the world's end-of-life material containing PGMs. Next slide, please. So just establishing our credentials, Johnson Matthey actually created the world's first commercially produced auto emissions catalyst in 1974 and started manufacturing them in the same year at our site in Royston in the UK, and we are still a leading provider of those systems. Next slide, please. So as has already been said, one of the key elements in minimizing the use of virgin materials is to design for durability, and that's one of the key ways in which we ensure sustainability here. These emission control catalysts have to last for as long as possible, so we design for that. So a catalyst, by definition, increases the rate of a reaction without itself being consumed. So you want to use materials that are going to stay put and stay active in these systems for the legislative life that it has to perform. And that is typically why platinum group metals see so much use here. Typical design, I mean, there's a lot of variations on this theme depending on the OEM, but if you're talking about a diesel fueled vehicle, the typical design for your emissions after treatment is going to be a diesel oxidation catalyst, followed by a diesel particulate filter, followed by selective catalytic reduction of NOx, nitrogen oxides, followed by an ammonia slip catalyst. So these all address different pollutants in that exhaust stream. I'm not going to go into too much detail. The point to make here is that the DOC, the DPF, and the ASC, these tend to rely on PGMs as catalysts, and it's just the SCR that makes use of other metals for catalysts. So particularly when you're talking about modern heavy-duty diesel after-treatment systems, designing for durability is really a key challenge. It's not easy to do, but we have to do it. We have to achieve high mileage without parts replacement or with minimal parts replacement. And with good maintenance, these systems should perform well beyond the warranty and legislated mileage period, which obviously in the case of these heavy-duty diesel vehicles is considerable. Now, the DOC and the SCR and the ASC, you can say in broad terms, these are dealing with gaseous pollutants. So basically what they're doing is they're taking a harmful gas and performing a chemical reaction to reduce that to a much less harmful gas, to harmless gases. The DPF is slightly special. You could kind of say it deals with the solids in the system. So let's just take a look at the DPF on the next slide. So here we really have to design for regeneration. These DPFs, they capture the unburnt hydrocarbons, so that's soot, and the inorganic particles, which is ash. So the filter is literally trapping these solids and filling up with them. The soot can be burned off. That typically requires a higher temperature than you see in normal running of the system. So either that will happen periodically in normal running at very high engine speeds, for example, or through a managed event through the engine control system, periodically having those regeneration events to burn off the soot. And that is catalyzed to promote that oxidation reaction as efficiently and as quickly as possible. Ash, as you'll know from your own barbecues, you can't burn that off, that remains. So we design the filter such that it is large enough to contain the volume of ash that will be generated over the legislative mileage period of the vehicle, and it'll fill up with that ash, but without compromising the performance of the filter to continue to reduce the emitted pollutants below the legislated limit. Now, what we have seen is really quite innovative approaches, third-party methods actually looking at removing those DPFs, flushing them, and putting them back in for reuse. So really interesting to see those innovative methods coming through for reuse. But ultimately, if we're talking about using PGMs, we do need to look at the circular economy of those. They are not geologically abundant metals. They're very valuable metals, obviously, but they're industrially incredibly important metals. So we don't, we do want to recover them. And the good news here, as we'll see on the next slide, is that recycling of platinum group metals from automotive emissions control is a very, very well-established process. It's been happening for decades, ever since we started making these things. And we do go into much more detail on this in our circularity white paper, which is available for free download on our website. So I'm not going to go into too much detail here, but just to point out that we've got these well-established loops. So the closed loop shown in the kind of green there is when we're manufacturing these things and they're going onto the vehicles. That production scrap is retained in a closed loop. The production scrap is sent back for recycling and for refining. That metal is recovered and it is retained within the manufacturing loop. Really important to say that when PGMs are recycled, they are not downcycled. So the recycled PGM has exactly the same properties as the virgin PGM, and it can be reused indefinitely. Now, a closed loop won't work for the end of life platinum group metals. So those metals go on to the vehicles. The vehicles are sold all over the world, potentially resold multiple times. You can't have a closed loop there because the original purchaser and user of the metal does not retain ownership. So there we have an open loop, which again works very effectively. And we've got specialist collectors who go after the catalytic converters on end-of-life vehicles, or indeed catalytic converters that have been removed because they themselves are at the end of their life, and they collect those and send them through to refiners such as Johnson Matthey to recycle the platinum group metal, recover it, and resell that metal again. And quite often that same metal is going back into new automotive emission catalysts. So a really good example of circularity in action. Now, The open loop is not as effective as the closed loop. It's a dispersed resource. Collection practices are not 100% efficient for a number of reasons. So we do think about 30% of the platinum group metal that is or has been used on in catalytic converters won't ultimately be recovered. That is something we can look to improve. But the good news is 70% will come back for reuse. Next slide, please. Now, this is really, really important because when you look at where platinum group metals go, ICE vehicle after treatment is by far the biggest user of platinum group metals that are newly supplied to the market every year. So forgive me, these donut charts are a little bit out of date, but it's pretty much the same proportions in each year. So you can see of the three metals that get used in catalytic converters in emissions control, that's platinum, palladium, and rhodium. These are really, as I said, very industrially useful metals getting used in a broad range of different sectors, broken down here on the donut charts. Platinum, of course, is also a jewelry metal, but by far the biggest user of these three metals is emissions control for vehicles, the automotive sector. So the fact that that metal is ultimately going to be recycled is very significant for platinum group metals indeed. And on the next chart, just to really underscore that significance, we can see that when we look at the sources of platinum group metals supplied to the market, so this was supply in 2024, this is the metal that went newly onto the market in the year, you can see how important the urban PGM mine from ICE vehicles actually is. So because PGMs are not downcycled, secondary material is physically identical to primary material. When you're looking at supply of PGMs, you do need to consider both the primary mine and the urban mine. The primary mine, the South African PGM mine, is by far the biggest source of platinum group metals, but the second largest source of platinum group metal supply is now the auto urban mine. So really, really significant for both the structure of platinum group metal supply and demand. And on the next slide, we'll just break that down slightly differently. So on average, if you look at what's supplied to the market, about a fifth of the platinum and almost a third of the palladium and the rhodium is now recycled metal. So this is the circular economy in action. We're seeing that recycled material really starting to displace virgin material to a fairly significant degree already. And just the chart at the bottom is just underscoring that that urban mine is going to keep producing recycled platinum group metal for a very long time to come. So that chart's just showing palladium for the sake of illustration that went onto new vehicles made in the US and Canada every year since 2002. A lot of that has already come back, hundreds of tons still waiting to be recovered. So really quite important also from a resilience of supply chain point of view. Next slide, please. However, when we look at the platinum group metals used on newly fabricated products, so whether that's emission control catalysts or process catalysts or other products such as alloys, of that, 60% of that is now recycled. So how does that stack up with what I've just shown you? It's a bigger number. And the answer is that it's the closed loop. So many users of platinum group metals are now doing that in a closed loop, recycling their metal and remanufacturing their equipment or remanufacturing replacement catalyst using their retained platinum group metals. And that's really significant when you think that a recycled a gram of platinum group metal is going to have up to 97% lower greenhouse gas emissions associated with it than virgin platinum group metal. So really significant from a sustainability point of view. Next slide, please. So just to make the point here, that's why a lot of these sectors don't look that significant compared to a vehicle after treatment. It's because for things like process catalysts to make chemicals and fuels, or PGM alloys to make display glass or fiberglass, they are reusing that metal in a closed loop, so it doesn't appear on those charts because it's their own metal they're reusing. And on the next chart, just to make the point, we really want to work with our customers to close the loop wherever possible, to keep the PGMs in your hands for reuse as much as possible. It's obviously a really good thing from an environmental sustainability point of view, but it's also important for economic sustainability. So we really work with customers to try to close the loop wherever possible. Last slide from me. Lots more information on platinum group metals if you want it on our website. And I think on the final slide, I give you my email address. If you're interested in finding out more, please do get in touch. And on the next slide, please. Thanks very much.
Very nice, Marjorie. Thank you so much for that. And boy, it's really amazing how much is going back into the system there. I never realized that the extent. It's quite impressive. We are now at a point where we can begin to have our Q&A discussion. And I want to thank all the attendees for submitting questions throughout today's session. We're going to start at the beginning, those first questions. And Patricia, you would like to answer the first question there. What's the warranty period for a reman engine? Is it the same as a brand new engine?
Yeah, thanks, Alan. It is the same as new. What I'll add on to that is that it does vary by application because all applications are not treated equally. So, but the general answer is that it is the same as new, which I think Kevin also mentioned as he was going through his slides. I think that's pretty standard, that it is the same or better than.
Okay, very good. We've got another question there for you, I think, Patricia.
Okay.
Under what circumstances would an engine come back to Cummins within 18 months of product launch? Is that from an accident, the chassis being totaled, or how would that work?
Yeah, it could be. I would say it depends. I know that's not a good answer. Sometimes it depends, but it truly does in this case. In the event that the customer does have an accident, and the chassis is damaged, then we certainly look to collaborate and work. The other examples is if for any reason there is a warranty, there's a failure of some sort and it is covered under warranty, then the customers definitely have an option to swing in a reconnage.
Okay, very good. Let's see, we've got some additional questions here. Let me go. Kind of lost my spot here. Sorry about that. How old is this? Is I think a general question for the group here. How old is too old to remanufacture? And then secondarily, what if one is trying to add a new technology, like let's say hydrogen for internal combustion engines to the core? How does that impact things? How old is too old?
I'll maybe jump in on how old is too old. I think similar to Patricia's answer, I think the answer is it depends, but the question would be what is and Patricia had a great life cycle chart, but the question would be at what point in the life cycle is it, and does it make business sense to begin to remanufacture something? If there's still a good field population, I mentioned we're remanufacturing engines that were put on machines in the late 70s. Still makes sense for us. Obviously, that is going to continue to dwindle, but I think that it's going to depend a lot on the field population and really the customer needs.
I'll add a little bit to that, and I think Kevin's spot on. It depends, but I think a lot of time the limiting factor, a lot of cases for us is the availability of replacement parts usually limits the life considerably. Because although we do like to restore parts, at the end of the day, we don't get them all back. We can't use them all the time. Some of them will replace 100% of the time, regardless. And so as businesses decide to exit applications, if the new side dries up, that generally leads to eventually problems with supplying the remanufactured product as well.
Okay, very good, makes sense. Well, the other part of that question though was what about these new technologies? Let's say we know there's a lot of discussion about hydrogen for internal combustion engines. What can we think about that in terms of remanufacturing? Is that going to be possible for those kind of engines? And we've talked a lot about diesel. I'll throw this one in from my own perspective here, but does all this still apply to natural gas as well? Any gaseous fueled as well as any compression engine?
I'll jump in there on that one. Definitely for us for natural gas, Alan, yes, the process is very much the same, whether we're remanufacturing the diesel or natural gas. Now the salvage technology may be different depending, but absolutely we remanufacture natural gas. And give me the first part of that question again. I think it was related to the new technologies.
Right, for hydrogen ICE, for example.
Yeah, so I would say as we continue to release the new technologies, whether it's the hydrogen or the battery, we're looking at it using similar questions that we asked ourselves in the early days for the diesel and the gas remanufacturing, but quite differently, respecting that the technologies are completely different. Do we need remanufacture or do we need repair models, depending on the technology?
Okay. Thank you for that. Jump around here a little bit before we jump into the future, but for engines that have been in production for many years, is there any opportunity to use some remanufactured components on a new engine rebuild or new engine build?
I don't mind jumping in here again. I will say no. We happened in one of our remanufacturing plants. We run assembly of new engines as well as remanufacture, and we have to keep those completely separate. Once you introduce a remanufactured component onto a new engine, it is no longer a new engine. And so that is a very, very strict rule and criteria that we have to follow before we have to reclassify that as a remanufactured engine. So no
That's the same at Caterpillar as well.
Yeah, same at John Deere. I think the other challenge is it's the new that's providing the eventual core. And so you'd be depleting your core pool. But certainly it's not something that we have done or would contemplate doing, to use a reman component on a new engine.
Okay, very good. Serena, we have one directed specifically for you. The remanufactured parts may have creep and fatigue failure issues. How are you regenerating the material to remove the fatigue, cyclic, and creep issues already induced? That's a very specific question.
Yeah, I mean, I think based on the wear and based on the fatigue, so we might have to rework those components to be able to reuse it. If we cannot able to remanufacture it, I mean, if the wear or the fatigue is so much on the component, we have to do a reverse engineering, especially if I'm not the design of that component. I have to do a reverse engineering just to have made that as a virgin, just one part, which has a high fatigue life, have to be made as a virgin and then use it, the other parts. That's why we have like a reuse rate of like 85%, and the remaining 15% sometimes because of this wear that you have to use virgin components.
Okay. Thank you for that. Here's one for a broad group, I think. Does unavailability of replacement parts discourage reman in any application more than others? So the example given was ancient switcher locomotives in particular. If I can't manufacture, the new product is too expensive, I'll just keep the unit limping along as its original designation, whatever that might be for emissions level. So is there any particular sectors that are more challenging than others?
I can jump in here. My view on that would be it's pretty universal. If you don't have replacement parts available, it's going to be difficult to continue a reman application going forward.
Yeah, and I think from a segment, sometimes in electronics is where you can run into issues with that. You get a lot of obsolescence, new generations of technology in electronics that come in pretty quick relative to some of the other things, and that's where you start to see some issues with long-term manufacturing. A lot of times is in the electronic space.
Okay. Is it safe to say then, at some level, if we have a particular application, let's say a row crop tractor that's sold, 100,000 or 200, 300,000 units in its lifetime, might be more akin to remanufacturing than, let's say, a unique some kind of construction machine that you only sold 10,000 over a 5 or 10 year period. Does those simple numbers of how big was the market also direct sort of what can happen with remanufacturing?
Yeah, Alan, that's a great point. I would say that is true. One of the things that's required is enough field population and enough core to sustain the product. And if there's more volume there's more likelihood. Obviously, there also has to be a business case. If there's just a few of a product out there, to implement the rigor that reman requires may not make sense versus just a rebuild strategy. So I do think that the volumes do matter in that.
Okay. Thank you for that. Here's a question. Does remanufacturing only apply to self-propelled equipment or also mobile and stationary equipment?
Yeah, I'll speak to that. As Kevin mentioned, the Reman Industries Council. That's a organization we're involved with, and one of the kind of unique things about that is it cuts across many industries, not just heavy equipment, mobile, but we have people that remanufacture office equipment, people that remanufacture medical equipment. So remanufacturing applies to many industries, not just mobile heavy duty equipment. And so if you reach out to some of those organizations, you get an opportunity to see how others are doing it, and things that in areas you might not thought would be possible to remanufacture. But I think the same situations apply. Customers are looking for how to lower their total cost of ownership. They're trying to reuse material for the environmental benefits. And so the applications are well beyond mobile heavy duty equipment.
Okay, thank you for that, Jeff.
Maybe just an additional plug for the RIC. If anyone is interested in learning more about that, certainly go out online, Remanufacturing Industries Council. Jeff says he's involved. He's actually the chairman of the board. So he's very involved. I serve on the board as well. And it is it's an opportunity for collaboration, education, and advocacy, and bringing multiple industries together around reman.
Okay. One of the questions that struck me as particularly timely, given kind of sort of the state of our world. This is Earth Day month, April, and we think about a lot of consumer products and things that if something breaks on it, you might go back to the manufacturer to fix it, or start to evaluate, can you fix it, and find out that no, there's really not any good option to fix or even repair it at some level. And so this question that's asked, I think, is particularly instructive. It says, it seems that remanufacturing is the antithesis of planned obsolescence. Does this shift the trend in the industry as a whole, or just for a segment of engine products?
That's a really good question. I'll go first here on this one. In terms of planned obsolescence, I think the way that we've thought about it over a number of years is that we're giving our customers an alternative or an option to continue to utilize product that they've fallen in love with. And I only say that because we still, I think Kevin and Jeff mentioned it, we have a lot of legacy product that customers say, this is the engine that works for me and I love it. So it gives us that opportunity to continue to allow customers to utilize that product. And if and when there is a product that becomes available that we recommend replace that legacy product, then we encourage them at whatever point they're comfortable with to make that change and make that adjustment. So you could look at it as a means or path to the end. But again, I think that's where that life cycle model really comes in handy. Hope that helps.
Great, thank you for that. So we're getting through the top of the hour here. The last question, let's talk about the future, and what about advanced technology, advanced emissions control engines? I think, those in the industry here know that the significant amount of change that's taken place in internal combustion engines over time with the introduction of particulate filters, SCR systems, et cetera. Are these more advanced technologies and emissions control systems engines harder to get into the remanufacturing, or about the same, or we're still learning? That's, I think, a question that everybody could kind of weigh in here too. Marjorie, how about from your perspective in terms of a supplier of some of these advanced metals and treatment systems for the catalyst? What's your sense of how the future technology and regulations are going to impact remanufacturing and recovery of those rare metals?
Yeah, from a critical metals point of view, I mean, battery vehicles use considerably more critical metals, kilograms and kilograms more critical metals than in either internal combustion engines or fuel cell vehicles. So, from a critical metal point of view, those battery vehicles are highly loaded. And if they cannot be effectively recycled, and recycled and retained within the loop, so recycled without downcycling, that is a challenge, and I know it's one that regulators and policymakers are really looking at, because some of the supply increases that will be needed for some of those critical metals for batteries are looking potentially quite unsustainable. So I think that critical metals challenge for battery vehicles is still one that probably needs to be fully addressed, but it's certainly one metric on which other technologies compare better.
Thank you for that. Anyone else want to weigh in on the future recyclability of more current generation product? How are we feeling about that?
I would maybe just add that, we're pretty new to the battery space at John Deere, but it is clear that the batteries by definition, by design, will lose their state of health over time, and to recover that in a true reman space is a big question mark. Certainly there's opportunities to rebuild or refurbish based on what has been damaged on a battery over time, but to increase state of health is not an option. So getting it back to a like new on a battery is very different than getting it back to a like new on an ICE engine.
Okay. One comment or question I skipped over here, I wanted to make sure we had a chance to get to. Do reman engines need to be recertified to the EPA standards?
No, because I'll answer here real quick, Jeff. Because we follow the same standards and requirements as new, the answer for that is no. Once they meet that standard, they meet the certification requirements.
Perfect. Thank you so much, Patricia, for that answer there at the end. So just to wrap up here, I think you've really seen a fantastic presentation this morning. Great diversity of approaches to remanufacturing here, but a lot of common thinking within the industry as well, not just for what we're doing today, but really designing for the future. And the value proposition, I think, was outlined quite well. And I think, as we said at the outset, the very mere practice of remanufacturing, to the extent that it's taking place today and continues to grow, is a key aspect about the sustainability of advanced internal combustion engines in the future. So really appreciate you all kicking off your week with us. We have another session coming up in May that's going to look at new manufacturing and sort of take a spotlight on how that's done. What does it take to build America's advanced internal combustion engines? And we hope that you might be able to join us for that. But I want to thank our panelists today, Patricia, Kevin, Srinu, Jeff, and Marge. Guys, great job for Monday morning. Everybody's really on the ball here. So thank you all for that. And we really appreciate you being here. For those attendees, any feedback you'd like to share our way is always welcome. You can use the various approaches outlined here on the screen, and visit our website to see any of our virtual events we've had in the past. And here's a list of a few of those. So with that, again, thank you all for our panelists for a great job this morning, and for our attendees for being here. Everyone have a great day.
Thank you.
Thank you. Take care.
Thank you.